staying in our home, we've just talked about our home theater PC. Let's say we have a lot of storage information that we want to save in our home. We want to have a centralized home server PC that we can use to store all of the information that we may use on a daily basis, whether it be files or videos. And we want to sort of centralize that on a large storage capacity PC so that we can just pull it from there when we need it rather than having to have it on our individual computers. Now, this home server PC is going to want to have components such as file storage, movie streaming, fast data retrieval and saving, and we may even want to include a backup in there because we don't want to lose all that data. One of our first configurations, one of our first considerations for our home server PC is going to be media streaming. Media streaming is going to allow us to actually connect to that home server PC and stream media, stream videos, or stream movies or television that we've purchased and we have saved as digital copies on that home server so that we can actually just store our information there and stream it from there rather than having to save it locally on our PC. Another option is family movies that are made and then saved, and we can just store them there, but rather than just storing them there, we can use media streaming so that we can watch them from that home server PC. We want to make sure that we enable Playback on our home server. This will be configured through our network and sharing system on Windows. Additionally, if we're running XP on this machine, we want to make sure that we install Windows Media Player. We want to install the latest version of Windows Media Player on this. We may decide to use an alternate media player, but as a standard streaming or playback service, Windows Media Player will generally give us what we need and will allow us, if we set our configurations properly on our connection and sharing center, we'll be able to enable that playback and we'll be able to watch our shared and saved videos on different computers. So in addition to our media streaming, we may also want to enable file sharing. File sharing is what will allow us to take those large reports that we've archived or the vast amount of pictures that we have saved that we don't want on our computer anymore and store them on our home server PC and pull them back later when we need them. But in order to enable this file sharing, again, we need to check with our network and sharing setup, and we want to enable file read-write. If we don't enable this, then we may actually have to be sitting directly at that home server PC in order to save or transfer files, and that can become very unwieldy and become a hassle to do. Rather than having to do that, we can just set it up so that we can remotely connect to the computer and save our files there, move them off of our PC, back them up, and then retrieve them later. In addition, we need to make sure that we configure this through our just standard share tabs on our server. So our last sharing configuration that we'll have on our home server PC will be printer sharing. Maybe we have one big home printer that we have plugged into our home server that we use in order to just download our drivers onto and manage all of our print queues, and we don't want to have to take every other computer and connect to it manually. So we just set up our home server and we manually and physically connect our home server to our printer, and then we just share that printer out to all of our other computers that can connect to the server. This server will become sort of the managing server for that printer, and we'll just send the jobs to this server, which will then pass them along to the printer. This makes it a lot easier to manage print jobs, to manage our different print queues, and to keep that printer centralized and from having to go all the way into the print room to plug in and print. We can just do it remotely and manage it a lot more easily. But again, we want to make sure that we enable that print sharing on the home server, and we want to run through that configuration properly because it's not really something that it will just set up itself. We actually have to go in there, we have to add that printer and allow it to share so that we can connect remotely and utilize that feature. Moving on from our configurations on our home server PC, what's some of the actual physical components that we need to make sure that this has? Well, one of the first is going to be a Gigabit NIC. NIC stands for Network Interface Card. It essentially allows us to have a bit of a faster connection, a faster data transfer with our home server PC. We've talked in earlier videos how you really can't just add a Gigabit NIC into something and then expect all of your connections to that device to be running at that top speed. You actually have to update your entire infrastructure and all of your connections between your home server and your computer would have to be running at that gigabit speed in order to achieve the maximum throughput. But the Gigabit NIC is a good place to start when you're building your home server PC. This would make sure that you have that groundwork laid and you don't have to upgrade that NIC later, or if you're in an environment where you already have all the cables set up and your personal and your other personal PC that you're using is just your standard computer, or your laptop also has that Gigabit NIC connection, then you can jump right in there and get a faster throughput. This is going to help us with fast data transfer as well as media streaming. This Gigabit network interface card may already be integrated into the system that you're buying, or if not, maybe something, or is something that you can actually add on through an additional expansion slot. Now, you always want to make sure that, again, all of your systems support the Gigabit Ethernet. And if you're going to add this onto your system, make sure that your system actually supports it and that you're using the correct drivers when you're installing the card so that you're getting that maximum throughput and you're not running into any issues. Our last component for our home server PC is going to be our RAID array, a redundant array of independent disks. Now, our RAID array, again, comes in a couple different versions. We have RAID 0, RAID 1, and RAID 10. These are the three different types of RAIDs that we're going to be talking about when it relates to our home server. RAID 10 being really RAID 0 plus 1. So it's essentially those two types of RAIDs together. Now, just as a quick recap of our different RAID array systems. When we're talking about RAID 0, we're talking about faster boot times, faster access to information and saving of information, because what we want to think of when we're thinking of RAID 0 is striping. So with RAID 0, we need to have at least 2 hard disks in our RAID system set up. And with RAID 0, as our computer is booting up and saving information, it doesn't have to go through our entire disk and move to different locations to read or write or save. It simply just saves information where it can most quickly access it. So think of these as our 2 different hard disks, and we have our different layers, we have our different platters. And with RAID 0, that's going to be fast, so our faster boot times, because it's just going to stripe across and it's just going to put the information as quick as it can wherever it needs to and read and write from it as fast as possible. So fast boot. Now, our RAID 1 is actually going to be redundancy. So say we're using our home server in order to store information, to back up files. We're not as concerned about speed as we are about redundancy. With RAID 1, similar to RAID 0, we need 2 disks, but in RAID 1, we use what's called mirroring. Now, mirroring simply writes what's on one disk to the other disk simultaneously. So as it's writing a bit of information on our first disk, it mirrors that information onto our second disk. It's not any faster. It's actually a little bit slower than just writing to one standard disk, whereas RAID 0 improves our speed. RAID 1 would slow down a little bit because we're mirroring to both of those drives at the same time. We're still getting that redundancy that we may need, that redundancy that we want on a home server that's storing important files. So RAID 1 would be redundancy. Now, we talked about how RAID 10 is RAID 0 plus 1. So as you can guess, RAID 10 is going to give us both fast boot, and it's also going to give us that redundancy. So RAID 10 actually requires 4 disks, or 4 hard drives. And what RAID 10 does is it does that striping that RAID 0 does for us, and it also gives us that mirroring that RAID 1 gives us. So the drives work in pairs, pair 1 and pair 2. Or rather, pair 1 and pair 2. So across these two, we'll just get the quick striping, writing the information as fast as we can, while these 2 disks actually become mirrors of these 2 disks. So we have that redundancy. That way, if one of our disks goes down, say if our disk right here dies, we still have a complete backup of that disk on our mirrored disk here. So again, this requires at least 4 disks in order to run striping with mirroring, and that will be our RAID 10. So as we can see in our home server PC, the types of setups we're going to look for is we're going to want to allow media streaming, file sharing, and print sharing in order to get the maximum use of that home server. And we're going to be wanting to get a Gigabit NIC in order to have that fast transfer times. And we're possibly even going to want to set up a RAID array to allow for fast boot times and redundancy in our disks, depending on which type of RAID array we use to save all of our information onto that home server PC.